Unlocking the Mysteries of Space, Orbital Inclination Explained. Hello, everyone. Welcome back to our channel, where we make learning English fun and engaging. Today, we're embarking on a journey beyond our atmosphere to understand a fascinating concept in astronomy and space exploration: orbital inclination. If you've ever wondered how satellites orbit the Earth or how planets align with each other in space, you're in for a treat. So, let's dive into the cosmic world of orbital mechanics and unravel the secrets together. Orbital inclination is a term that might sound complex at first, but it's actually based on simple geometry. Imagine the Earth, like a giant magnet, pulling objects into an orbit around it. These objects, such as satellites or the Moon, don't orbit in random patterns. Instead, they follow specific paths around the Earth. Orbital inclination is the angle between this orbit path and a base reference plane. The most common reference plane is the equatorial plane of the Earth, which is an imaginary flat surface extending out from the Earth's equator. In simpler terms, think of orbital inclination as the tilt of an orbit. It tells us how much an orbit is slanted compared to the Earth's equator. This tilt is measured in degrees, from 0 to 180. An inclination of 0 degrees means the orbit lies exactly on the equatorial plane, while an inclination of 90 degrees indicates a polar orbit, where the object travels over the Earth's poles. Understanding orbital inclination is crucial for several reasons, especially when it comes to launching satellites and planning space missions. The inclination of an orbit determines the coverage area of a satellite, meaning which parts of the Earth it can observe or communicate with at any given time. For example, satellites in a low Earth orbit with a near equatorial inclination can provide detailed observations of tropical regions. Moreover, orbital inclination plays a significant role in fuel efficiency and mission planning for spacecraft. Changing the inclination of an orbit requires a lot of energy, so choosing the right inclination from the start is vital for the success and cost-effectiveness of space missions. Orbital inclination not only affects how we observe Earth but also how we explore other planets and the Moon. Missions to other celestial bodies must carefully calculate the inclination to ensure they can enter orbit around their target and achieve their scientific goals. For instance, a mission to study the polar regions of Mars would require a different orbital inclination than a mission focusing on the Martian equator. Additionally, understanding the orbital inclinations of planets helps astronomers study the dynamics of our solar system. It reveals how planets interact with each other and can even help predict future positions of planets and potential asteroid impacts. I hope this journey through the stars has illuminated the concept of orbital inclination for you. It's a fundamental aspect of understanding how objects move in space and has profound implications for everything from satellite TV to interplanetary exploration. Remember, every time you look up at the night sky, there's a whole universe of physics and geometry dancing above you. Thanks for watching, and we hope you found this video helpful. Stay curious, and see you in our next adventure into the wonders of the English language and beyond.